Hi everyone, in today's video we are going to talk about caching, but before moving to caching, let's take a real life example. Let's say I'm thirsty and I want to drink water, and I go to the kitchen, drink water, come back and start doing my work again, and then I feel thirsty again, and then I go to the kitchen again, drink water and come back. So instead of going to the kitchen again and again, what I can do is I can have a water bottle on my desk and I can just grab it and drink water. That saves time. So that water bottle is what cache is. Now let's move to the theory of caching. So let's start. Let's say we have two Kubernetes pods S1 and S2. Now both of these are communicating to the database, sending the request, getting the response. Now let's say we have frequent calls for some of the requests. So now instead of fetching the data again and again from the database, what we can do is we can fetch the data from a cache. So let's go. This is again S1 and S2, and this is our DB. Now again the question arises, where should I place my cache? What I can do is I can place it either near the pod or I can place it near the database. So let's say first we take the case of placing it near the pods. So if we place it in the pods, what will happen is when we have a request, the pod will first check in its cache. If it's a cache miss, then the request will go towards the DB and also update it in the cache. Now this type is called as in-memory cache. But the memory in our servers, or we can say our pods, is limited. So let's say if we have a lot of data coming in towards our pods, what will happen is we will run out of memory soon and will get an out of memory error. So how can we avoid getting an out of memory error? So let's discuss. We have two types of scenarios for out of memory error. One is TTL, which is time to live. So what I can specify is I can specify a particular time period for this. Let's say 3 hours. So after 3 hours the cache will be automatically cleared and we can have our data updated. So whatever entries are longer than 3 hours, they will be removed from the cache. Or the second scenario we have is having a limit for the cache. Now coming to the other type of cache, in which we place it closer to the database. This is our S1 pod, this is our S2 pod, this is our database. Now we place the cache closer to the database, let's say C1, and now both of these pods will send request to this cache. If the request is found in cache, it will be returned, or else if it's not present in the cache, then it will fetch from the DB and update it from the cache. So these are the two scenarios. Now, how can we implement this cache? We can use AWS or Azure or any cloud platform to host our cache, and this type of cache is called distributed cache. Now let's discuss about the caching strategies. We have two types of strategies in caching. One is cache through and one is cache back. So what happens in cache through is, let's say this is our pod S1 and this is our cache C and this is our DB. We write the update to the cache first and immediately write it into the DB. But what happens in cacheback is, this is a pod cache C DB. So the data is first updated in the cache but is not immediately updated to the DB. What happens is we have our updates and after a specified period of time we send batch entries into this DB. Now when we send batch entries we need to make sure that we take into account the data inconsistency that we can have. So that's it about cache in this video, and let me know if you guys would like to have a code implementation for the cache in any language. Thank you guys. Bye.